Right now, while you are reading this sentence in the warm glow of a screen, there is a machine roughly 15.5 billion miles above your head, moving through the darkness at more than 10 miles every second, and it is trying to tell you something. It has been trying for decades. Before we get into it, if you're new here, this channel covers space and astronomy stories the way working scientists actually talk about them, without the exaggeration. If that sounds like your kind of channel, the subscribe button is right there, and it genuinely helps this content reach more people who care about getting the science right. Now, the signal this machine is sending right now is not new. It left the spacecraft almost a full day ago, crawled across a gulf so wide that light itself needs nearly 24 hours to cross it, and it is only reaching Earth in this moment, faint, whisper thin, so weak that the dish catching it has to strain against the background hiss of the entire universe just to hear it. And here is the thing almost nobody stops to consider. The transmitter aboard Voyager broadcasts with about the power of a refrigerator light bulb. That is the entire strength of the signal that has to cross 15.5 billion miles of space and still be understood when it arrives. And the spacecraft that sent it does not know if we received it. It cannot know. By the time its message lands, the craft has already flown another 1.5 million kilometers further out into a region of space that no probe, no telescope, no theory had ever truly touched before it got there. And somewhere out along that impossible road, Voyager 1 ran into something that was not supposed to be there. Something that our best models, our sharpest minds, our most confident predictions had gotten wrong. NASA confirmed it, and once you understand what it actually hit, the sky above you is never going to look quite the same again. So stay with me, because to understand what happened out there in the dark, you first have to understand just how far away this machine really is and how absurd it is that it is still talking to us at all. Picture the distance between the Earth and the Sun, 93 million miles. Light from the Sun takes about 8 minutes to make that trip. Now take that distance and multiply it by roughly 170. That is where Voyager 1 sits at this very moment, so remote that in late 2026, it will cross a threshold no human creation has ever reached. It will become the first object we have ever made to sit one full light day away from home. Say that slowly, a light day. The distance light itself, the thing that circles our entire planet 7 times in a single second, needs an entire 24-hour day to travel. Voyager took nearly 50 years to cover the same ground, and it is still going. To grasp what Voyager 1 collided with, you have to rewind all the way back to a September morning in 1977. A rocket lifts off from Cape Canaveral carrying a spacecraft that weighs less than a small car and thinks with a computer millions of times weaker than the phone in your pocket right now. The engineers who built it had a modest goal, at least by cosmic standards: fly past Jupiter, fly past Saturn, send back photographs of worlds humanity had only ever seen as smudges of light through a telescope. That was the mission, a grand tour of the outer planets expected to last perhaps 5 years. Nobody in that control room seriously believed they were building something that would still be operating when their own grandchildren were grown. And yet, here is the first twist in a story absolutely full of them. Voyager did its job at Jupiter, capturing the Great Red Storm and the sulfur volcanoes erupting on one of its moons. It did its job at Saturn, threading through the rings. And then, with its primary mission complete, Voyager 1 simply kept going. It had built up so much speed from the gravity of those giant planets, flung forward like a stone from a slingshot, that nothing was ever going to stop it. It was leaving, not just leaving Saturn, leaving everything. And as it climbed away from the sun, decade after decade, it began to approach a boundary that scientists had theorized about for generations, but had never once been able to visit. Think about our sun for a moment, not as a ball of fire, but as something that breathes. It exhales constantly, a supersonic wind of charged particles streaming outward in every direction at over 1 million miles per hour. That wind carves out an enormous bubble around our entire solar system, a vast protective shell that surrounds the sun and all its planets and stretches billions of miles into space. Scientists call it the Heliosphere, and everything you have ever known, every human who has ever lived, every war and love song and sunrise in the whole of history has happened inside that bubble. Nothing we had ever built had left it. The bubble had an edge, a place where the sun's outward breath finally weakened enough to be pushed back by the cold pressure of the space between the stars. They called that edge the heliopause. And nobody knew how far away it actually was or how sharply it would announce itself. Every prediction was theory built on theory, because we had never been there. The only way to ever truly know was to send something all the way out to the edge and have it radio back what it found. That is what Voyager became. Not a probe of planets anymore, but a lone scout sent to map the wall of our world. Here is the part that almost nobody talks about, the part that turns this from a story about a spacecraft into a story about the limits of human certainty. When scientists imagined the edge of the heliosphere, they expected a gradual thing, a slow fade, like walking out of a lit room into dusk. That is not what happened. On the 25th of August, 2012, Voyager 1's instruments recorded something that stopped the mission team cold. The particles from our own sun, the familiar rain of solar material the spacecraft had been swimming through for 35 years, suddenly and almost completely vanished. In their place came a flood of galactic cosmic rays, high-energy particles born in the death throes of distant stars, the raw radiation of the wider galaxy pouring in from all directions. It was not a gentle fade, it was a wall. And it took the scientists more than a year to be certain of what they were looking at, because the one instrument that could have told them instantly had failed decades earlier. So they had to wait. They had to listen. And then, in 2013, Voyager's plasma wave instrument caught it. The space around the spacecraft began to ring at a specific frequency, an oscillation that told the scientists exactly how dense the material around Voyager had become. And when they ran the numbers, the truth landed. The plasma density had jumped by a factor of roughly 20 times denser than the space the craft had been traveling through. Voyager 1 had not drifted quietly into the dark. It had slammed into a dense outer shell of interstellar plasma, a region compressed and piled up against the outside of our sun's bubble like water heaping against the hull of a moving ship. This was the something, this was the thing it hit. Not a rock, not a wall of stone, but a wall of another kind entirely, a barrier of charged particles marking the true edge of everything the sun has ever touched. And it should matter to you deeply, because in that single moment, at nearly 12 billion miles from home, a machine built with 1970s technology became the first object from Earth to physically cross out of our solar bubble and into the space between the stars. For the first time in the 4.5 billion-year history of this planet, something of ours was outside. And it was still transmitting, still sending, still functioning. Now, stop and sit with that. By the time humanity confidently declared that one of its creations had left the solar bubble, the event itself was already ancient. Voyager had crossed the threshold and kept right on going millions of miles deeper before we back on Earth even finished agreeing that it had happened at all. You do not witness a discovery at this distance. You reconstruct it after the fact from clues that arrived at the speed of light and still took nearly a day to reach you. Now stop and sit with this, because it gets stranger. When people hear that Voyager crossed into interstellar space, they imagine cold, the deep freeze of the void, and in one sense they are right. But the thing Voyager passed through carried a number attached to it that sounds at first completely insane. The plasma out there registered temperatures of tens of thousands of degrees. Some measurements pointed toward figures around 50,000 Kelvin, 50,000. That is not a typo. The space Voyager 1 flew into was, by one definition of the word, blisteringly, unimaginably hot, far hotter than the surface of the sun itself. And this is where the human mind rebels, because it does not fit. How can the cold, empty, deadly space between the stars be 50,000 degrees? And how did a fragile spacecraft fly straight through it and survive? Here is how to picture it, and this is the detail that tends to stick with people. Temperature and heat are not the same thing. Temperature measures how fast individual particles are moving. Heat is about how many of those particles there are to actually transfer their energy to you. Out there, beyond the heliopause, the particles are indeed moving ferociously fast, so by the strict physics of it, the temperature is genuinely enormous. But there are almost none of them. The space is so close to empty that even though each particle is a tiny screaming bullet of energy, there are so few of them striking the spacecraft that they cannot actually warm it. Imagine standing in a place with only a dozen molecules for every space the size of a sugar cube. The spacecraft in that searing 50,000-degree environment was actually cooling down, radiating its warmth away into the dark, growing colder by the year exactly as if it were sitting in a perfect vacuum. Both things are true at once. It is one of the most beautifully counterintuitive facts in all of space exploration, a place that is simultaneously among the hottest and among the emptiest regions a human object has ever visited. And this is the kind of discovery you can only make by physically being there, No telescope on Earth could have told us the temperature of individual particles at the edge of the heliosphere. It took a machine actually present with a sensor actually immersed in that plasma to report back the truth of a place we could otherwise only theorize about. But here is the twist that genuinely rattled the scientists. When Voyager 1 crossed that boundary, the team expected one specific thing above all else. They expected the direction of the magnetic field to change. Inside the heliosphere, the magnetic field points along the sun's own lines of force. Outside, in true interstellar space, the field should belong to the galaxy, pointing in a completely different direction. So the moment Voyager crossed over, the compass should have swung. It did not. Voyager 1 crossed the boundary, entered the denser interstellar plasma, confirmed by every other measurement that it had genuinely left the bubble, and yet the magnetic field just kept pointing in more or less the same direction it had inside. The rotation the scientists were waiting for simply never came, and that is not a small thing. It suggests that the influence of our sun reaches out far, far beyond the edge of its own bubble, that the boundary between us and the galaxy is not a clean line at all, but something blurred, layered, tangled. Think about what that actually means. We drew a map of where our solar system ends, we were confident about it, and then we sent a machine to the edge of that map, and the machine radioed back that the map was wrong. When Voyager 2 crossed the same boundary years later, at a completely different point along a completely different path, it confirmed the same strange result. Two spacecraft, two locations, two crossings separated by years and billions of miles, both telling us the same humbling truth. The reality out there did not match the theory. It never fully does. And that is the quiet heroism of a mission like this. Voyager's greatest contribution may not be the things it confirmed, but the things it broke, the confident predictions it flew straight through and shattered, forcing an entire field of science to become humbler about our true place in the galaxy. The edge of our solar system, it turns out, is not a wall at all. It is a shoreline, complicated and layered, where the sun's domain and the galaxy's domain blur into one another across a region far wider and stranger than any clean line on a diagram. And here is why this should matter to you, sitting on a small, warm planet deep inside that protective bubble. Everything Voyager measured out there is not trivia. It is the discovery of the actual boundary of your home. That heliosphere is not just a curiosity, it is a shield. It is the reason the deadly galactic cosmic rays that flooded into Voyager's sensors the instant it crossed the line do not flood in the same way here on Earth. Our sun's breath holds back a significant fraction of the raw radiation of the galaxy, and Voyager 1 flew to the very wall where that protection ends and measured for the first time in history exactly how much fiercer the universe gets the moment you step outside. When people talk about someday sending humans to other stars, this is the real gauntlet, not the empty distance, the radiation, the environment. On the other side of that wall, the one Voyager is sitting in right now, is a place that would slowly and quietly kill an unprotected human body over the course of such a journey. Voyager scouted the far side of the only wall that has ever kept our species safe, and it sent back the first honest report of what waits beyond it. And it did all of this using a computer with less memory than a cheap greeting card that plays a song when you open it. Sit with the improbability of that. A machine designed in an era of rotary telephones powered by a slowly decaying lump of plutonium is right now, this second, doing frontline science at the literal edge of the sun's reach. And it is the only tool humanity has ever possessed that can do it. There is no backup out there. For the questions Voyager can answer, it is the only instrument in existence, and every year a little more of its power fades away, because that is the ticking clock underneath this entire story. Voyager 1 runs on a generator that turns the heat of decaying plutonium into a trickle of electricity, and plutonium, by its nature, decays. Every single year, the spacecraft has a little less power than the year before. It is not a matter of if the lights go out, it is a matter of when. To keep the mission alive, the engineers have spent years playing a slow, agonizing game of triage, choosing which instruments to switch off so the most precious ones can keep breathing a little longer. They have already turned off the cameras. The eyes that gave us the pale blue dot, that famous photograph of Earth as a single pixel suspended in a sunbeam, have been dark for decades now. And here is a detail that stops people in their tracks. Because Voyager is so far away that a command takes almost a full day to arrive and any answer takes another full day to return, every decision the team makes is a leap of faith across a 2-day silence. They send an instruction into the dark, and then they wait. Not long ago, the spacecraft began sending back a stream of meaningless gibberish, its aging brain apparently scrambled, and for a while it looked like this might finally be the end. The team, working across that brutal communication gap, became detectives, sending a query, waiting 2 days for a garbled answer, forming a hypothesis, sending another command, waiting again. Imagine trying to repair a computer when every keystroke takes 2 days to register, and the computer is drifting through interstellar space 15 billion miles away, and if you get it wrong, you might lose it forever. And somehow, against those odds, they traced the problem to a single failing piece of memory, rewrote the affected code, found somewhere else in the spacecraft's ancient memory to put it, and sent that fix across the void. And 2 days later, Voyager answered, clearly alive again. But everyone involved knows the arithmetic. The propellant that keeps its antenna pointed at Earth could freeze. The power could dip below the threshold that keeps the transmitter warm. And if that antenna ever drifts even slightly off target, that will be the end. We will not have lost a signal. We will have lost the ability to ever hear it again. The most distant conversation in human history will simply stop mid-sentence forever. And yet, even when Voyager 1 finally falls silent, it will not stop. The transmitter will die, but the spacecraft will keep flying, coasting outward at over 35,000 miles an hour into the interstellar dark. It carries no engine to slow it, and there is almost nothing out there to slow it down. So it will simply continue mute and blind and cold for not hundreds of years, not thousands, but tens of thousands of years, drifting through the galaxy on the momentum it stole from Jupiter and Saturn back in 1979. And bolted to its side, it carries something extraordinary, placed there on purpose by people who understood exactly what they were doing. A golden record, a phonograph disc plated in gold to survive the eons, containing the sounds and images of Earth, greetings spoken in 55 languages, the sound of rain, of surf, of a human heartbeat, of a mother speaking to her child. Music from Bach to Chuck Berry to folk songs from cultures scattered across our world, the whale songs of our oceans. It is quite literally a message in a bottle cast into the cosmic ocean, aimed at no one and at everyone, a note from a civilization that wanted the universe to know it had existed. Think about what that means. Long after every person reading these words is gone, long after the cities we live in have crumbled, potentially long after the human species itself has changed beyond recognition or vanished entirely, that golden record will still be out there, still riding on the back of a silent spacecraft, still carrying the sound of a heartbeat and a mother's voice through the space between the stars. In about 40,000 years, it will drift within a couple of light years of another star, and it will keep going long after that on a lonely orbit that could last millions of years, because in the near perfect emptiness of interstellar space, there is almost nothing to erode it. Voyager 1 may be the single most durable thing our species has ever made. Not our monuments which fall, not our art which crumbles, not our written words which fade. This, a car-sized machine whispering to us right now from the edge of the sun's reach, destined to outlast every other trace of us by an almost incomprehensible margin. Here's the part that tends to sit with people the longest. When that golden record was made, it was engraved with instructions, a kind of cosmic user manual etched in symbols, showing through a map of pulsars where in the galaxy the spacecraft came from, a map back to Earth. The people who built this thing were not just saying goodbye. They were, in the most hopeful and vulnerable act imaginable, leaving directions home. And there is something almost unbearably tender about that when you set it against what Voyager actually is now, a fading machine at the edge of the known, still faithfully turning its ancient antenna toward a pale blue dot it can no longer see. It does not know if we are listening. It just keeps sending on the pure act of faith that someone on the other end still cares enough to point a dish at the sky and catch its voice before it slips below the noise forever. And someone does. Right now, tonight, there are people whose entire job is to listen for that whisper, to strain enormous dishes against the roar of the cosmos, to pull one dying spacecraft's signal out of the dark. They are keeping a conversation alive across a gulf so vast that the words themselves are a full day old by the time they land. When Voyager 1 crosses that one light day threshold in late 2026, becoming the first thing we have ever made to sit a full day of light beyond us, It will be a milestone worth pausing on, not because a boundary in space actually exists there, but because of what the number means. It means we built something out of aluminum and plutonium and 1970s ambition that reached so far it now takes light itself an entire day to catch it. It means a species confined to one small world managed to throw a piece of itself so far into the dark that the very fastest thing in the universe needs 24 hours to make the trip. So the next time you step outside at night and look up, I want you to try to hold two things in your mind at once. The same way that plasma out there is both scorching hot and freezing empty. The first is how small we are. One planet, one pale blue dot, one thin bubble of solar wind wrapped around everything we have ever loved, adrift in a galaxy so large that our farthest ambassador, after nearly 50 years of flight, has only just barely reached the doorstep. The second is how far that smallness managed to reach anyway. Because somewhere up there, past the point where the sun's light becomes just another star, past the wall of plasma that Voyager slammed into and measured and radioed home about, past the boundary where the map we drew of our own solar system turned out to be beautifully, humblingly wrong. There is a machine with our fingerprints on it, still moving, still carrying our heartbeat and our music and our directions home, still, for now, whispering back to us across a distance the human mind can name but cannot truly feel. It hit something out there that we did not fully understand, and in doing so, it taught us the real shape of our own home, the true edge of the only shelter our species has ever had. And it is not finished teaching us yet. There are questions it is answering this very second in signals that will not reach us until tomorrow. It will outlast us. That is the humbling truth at the center of it. We spend so much of our lives worried about being forgotten, about whether the small span of a human life leaves any mark at all on a universe this vast and indifferent. And here, drifting silently through the dark, is a quiet answer. We made something that will endure, carrying in its golden cargo the simple, stubborn insistence that we were real, that we felt things, that we looked up at the sky and refused to be content with wondering. Long after this planet has forgotten the names of everyone who built it, Voyager will still be out there in the silent dark, carrying the sound of who we were. If that thought moves you even a little, the way it moves me, then take a moment to sit with it before the world pulls you back. And if you want to keep chasing these stories about the strange and staggering edges of what we know, stay with me here and let us keep looking up together, because the universe is not finished surprising us, and neither somehow is a 50-year-old machine at the edge of everything still faithfully sending its voice home.